Hi there, I'm Ben the Tutor, and I'm trying out a new setup. I'm recording in my kitchen today because there's more natural light, so hopefully this looks a little bit better. Okay, today I want to talk about sequences and series, and we're just going to start out with the very first idea. And the first thing to say is the names. So there's a thing called an arithmetic series and an arithmetic sequence. So you see here we have the numbers 3, 7, 11, 15, and 19. And if you just think about it, each one's going up by 4, 4, 4, 4. So something that was just increasing. It's like arithmetic, just adding 4 each time. So this is an arithmetic series. If I went 3 plus 7 plus 11 and just kept adding all the things, then this would be an arithmetic sequence. So a series is where you just go along, and a sequence is when you add all of them. Okay, so we add some numbers. First of all, we add a number that we call n, which is the index. That is, what term is this one? What is the index of this term? And the index is like a way of identifying the numbers. So the first number is 3, and its index is 1. It's the first term. And then 7 is the second term, and 11 is the third term. And we call them T1, and T2, and T3, and T4, and T5, and so on. I'll just do another one. Say we had this guy, 9, 14, 19, 24, and so on. So we call the first one T1, and the second one T2, and the next one T3, and the next one T4, and the index of the first one is 1, and then it's 2, and then it's 3, and so on. So if I named a guy, say call him T17, that is the 17th term. And so I want to know how to find the 17th term. And so I could go along and add 5. So 1, 2, 3, 4, 5, 6, 7, up until the 17th one. But there's actually a formula which we can use, which is very helpful. So T1 plus D times n minus 1. So D is the difference between each one. So here D is 5. I went up by 5 each time. And here n, if I'm asking about the 17th term, I want n to be 17. So I write 17. So T17. So T1 is 4, the first term, plus 5 times 16. Okay, let's see how good my math is on the spot. 16 times 5, 0, carry the 3, 80. So that's 4 plus 80. So that's 84. So the 17th term in this series is 84. So they kept going along. Let's just try another example. So if I had, you can go backwards actually, 3 and 1, negative 1, negative 3, negative 5, negative 7, and so on. So the first term, T1, is 3, and D, the difference, is negative 2. Each time going backwards 2. So say I wanted to know the 100th term. The 100th term. Now that would take a long time to figure out if I just kept minusing 2, but I can just use this formula. So T100 equals 3 plus, so D is negative 2 times 100 minus 1. So that is 3 plus negative 2 times 99. 99 times negative 2, 198 negative. So that's 3 minus 198. If you want to use a calculator, you can double check my math to make sure I got this right. And that's 3 minus 198. Again, you can use a calculator, but I'm pretty sure it's negative 195. Okay, so I'll just write down the general formula is Tn equals T1 plus D times n minus 1. Maybe you've seen this with slightly different letters. People use different names, but the idea is the same. So Tn, really important to understand this. So that is saying no matter what n I pick, I could pick an n. It could be 10, it could be 33, it could be 10,000. So if I want the third term or the 10th term or the 179,000th term, this is the formula to use. And I start with the first term plus the d for the difference times n minus 1. And this is how we find a term in an arithmetic series. Now there are some different formulas for the sequences. I'll do them a different time. Thank you very much for watching.